These are your notes for Unit 10, Day 2 of Pre-Calculus. If you would like to see the warm-up review question or any homework questions we covered in class today, just look at your finished notes. So today we are going to move on with our conic sections, and the next conic section that we're going to discuss are ellipses. So we'll talk about how to graph and analyze ellipses, and then we'll talk about how to solve some applied problems that involve ellipses. So what makes an ellipse an ellipse? So an ellipse is your conic section that looks like an oval. And so an ellipse can be longer left and right, or it can be longer up and down. So if it is a longer left and right, so if it's longer along the horizontal axis, then the horizontal line that cuts your ellipse in half is called the major axis. And then the axis that cuts the ellipse through the center that goes up and down, so the shorter axis would be called the minor axis. And then you have the points that would run along the major axis that form the endpoints of the ellipse. We call those the vertices. And then the 2 points that lay on the minor axis that also fall on the ellipse are called the co-vertices. So we can call those co-vertice 1 and co-vertice 2. And then within ellipses, you have two foci. And so some of you guys might have done this project in grade school where you took a piece of paper and you put two tacks in the center of the paper, a little bit spaced out from the center of the paper, I guess. And then you took a string and you tied it together. And then you took your pencil and you kind of pulled that pencil taut, like it sees over here. And then you make a circular motion with your pencil. That circular motion that's going to be formed is the ellipse. So those two tacks that you put in your paper would be the foci. And so what's going to be true about the foci is if you took the distance from one of the foci to a point on the ellipse, and then you found the distance from the other foci to that same point on the ellipse, and you found those distance, so let's call it distance 1 and distance 2. If you add up distance 1 and distance 2, that distance is going to be the same no matter what point you pick on the ellipse. So if I picked a different point down here and called it P2, and then found the distance from P2 to the first focus, and then from P2 to the second focus, those two distances, so we'll call that D3 and D4, that distance would be, the sum of those distances would be equal to D1 plus D2. And that's kind of the definition of an ellipse. So the equations of ellipses. So you can have up and down ellipses, or you can have left and right ellipses. But the equation of an ellipse would be x squared over a squared plus y squared over b squared equals 1. So if a is greater than b, and a is underneath x squared, then it's going to be a ellipse that's longer left and right. So for instance, if we had x squared over 16 plus y squared over 4, the vertex the center of this ellipse, since we didn't move the x or didn't move the y, the center of that ellipse is going to be at 0, 0. And then the number underneath the x, once you square root it, so the square root of 16, tells you how many units to move left and right from the center. So we're going to move left 4, 1, 2, 3, 4, and right 4, 1, 2, 3, 4. And so those are going to be the vertices of my ellipse. And then the number underneath the y, once you take the square root, tells you how many units to move up and down from the center. So the square root of 4 is 2. So we're going to move up and down 2 from the center, and those are the co-vertices of the ellipse. And then if you connect those points in an ovally pattern, that is going to be the ellipse with the center at 0, 0, and whose minor axis is the y-axis, and whose major axis is the x-axis. If we want an ellipse to be moved off of 0, 0 as the center, we could have something like x minus h squared plus y minus k squared, and then over a squared and over b squared equals 1. So we could have x minus 2 squared plus y plus 5 squared, and then over 9 and over 1 equals 1. So notice the a underneath the x squared is bigger than the b underneath the y squared. So the center for this ellipse, backwards thinking, it'll be at the point 2, negative 5. So 2 over and then 5 down. 1, 2, 3, 4, 5. So that would be the center for this ellipse. And then take the square root of what's underneath the x, and that's how many you move left and right. So we're going to move 3 left and right. 1, 2, 3. 1, 2, 3. So those are my vertices. And then take the square root of what's underneath the y. So the square root of 1 is 1, and that's how many you move up and down. So up 1 and down 1. And then connect those points, and that would make your ellipse, whose center is at 2, -5, and has vertices and co-vertices at the given points. Well, if the term underneath the y is greater than the term underneath the x, then your ellipse is going to be longer up and down. So if we had x squared over a squared plus y squared over b squared equals 1, where b is greater than a, then the ellipse is going to be longer up and down. So the minor axis will go up and down, or sorry, the major axis will go up and down instead of left and right. So we could have x squared over 4 plus y squared over 9 equals 1. So the center would be at 0, 0. And then we would go 2 left and right. And we would go 3 up and down. And then connect those. And that would represent that ellipse. Or we can move that ellipse off of the center 0, 0. So we could have something like x plus 1 squared over 4 plus y minus 3 squared over 16 equals 1. So the center of this ellipse would be at -1, +3. So -1, +3. There's the center of the ellipse. And then we are going to move 2 left and right. And we're going to move 4 up and down. One, two, three, 4. 1, 2, 3, 4. And then connect those. And that would be that ellipse. All right, so let's look at some examples. So let's find the equation of ellipse whose center is at the origin, so 0, 0, and who has one focus at 3, 0, and a vertex at -4, 0. So the center is at 0, 0. One focus is at the point 3, 0, so 1, 2, 3. So here is one of our foci. And then the vertex is at -4, 0. So 1, 2, 3, 4. So here's a vertex. So it's going to look something like this. So it's going to be a left and right. Well, I guess we can find the second vertex. So if one vertex is at -4, 0, then the other vertex has to be at 4, 0. So my other vertex is going to be at 4, 0, and this is -4, 0. And so then my other foci should be at -3, 0. And so again, we have a left and right facing ellipse. Whoops. Don't want to make that. So a left and right facing ellipse. So we're going to have an x squared over a squared plus a y squared over b squared equals 1. Well, I moved 4 left and right from the center to get to my vertices. So it's going to be x squared over 4 squared. So it'll be x squared over 16 because my a is equal to 4, plus my y squared over b squared is going to equal 1. All right, well, we need to find the foci. Well, you might remember, to find foci, the equation of your foci is going to be a squared minus b squared is equal to c squared, where a is greater than b. So if we did this, we have a squared, and then c, is going to equal the distance from the center to the foci. So to find the foci, you use the equation a squared minus b squared equals c squared, where c is the distance from the center to the foci. Well, in our case, we know the distance from the center to the foci. We moved 3 to go from the center to the foci. So this c is going to be 3. So I have 3 squared equals, we know a is 4, so 4 squared minus b squared equals c squared. So I have 16 minus b squared is going to equal 9. Then I'm going to subtract 16 from both sides, and I get negative b squared equals 9 minus 16 is -7. So b squared is going to equal 7. Well, now I can just plug that into my equation because that's what I need is b squared. So x squared over 16 plus y squared over 7 is going to equal 1. And that would be the equation for that ellipse. All right, let's analyze the equation. 9x squared plus y squared equals 9. Well, for an ellipse, remember, we need it to equal 1. So right now it equals 9. So to make this equal 1, I'm going to divide all of the parts by 9. So then I get x squared over 1 plus y squared over 9 equals 1. So now I have an ellipse. The center of that ellipse is going to be at 0, 0. And then I'm going to move 1 left and right. and I'm going to move 3 up and down. So 1, 2, 3, 1, 2, 3. And that would be the ellipse formed with the equation 9x squared plus y squared equals 9. So it would be an ellipse with the center at 0, 0. The minor axis would move left and right, and the major axis would move up and down. All right, let's find the equation of an ellipse having one focus at 0, 2 and vertices at 0, negative 3 and 0, 3. All right, why don't you pause the video and try this one. Okay, we have vertices at 0, 3 and 0, negative 3. So we know it's going to be an up and down ellipse, and it has a focus at 0, 2. So there's a focus. Well, we're going to have x squared over a squared plus y squared over b squared is going to equal 1. And we know the b is going to be bigger. So to find the foci in this case, we're going to take b squared minus a squared equals 1, where b is greater than a. And so to move, the center is in between the two vertices. So the center in between 0, negative 3 and 0, 3, the center is going to be at 0, 0. So I'm going to do my center at 0, 0. So that's not going to change x squared or y squared. And then I moved up and down 3 to get to each vertex. So my b is going to equal 3. So b squared is 9. I don't know what a squared is, but I know that to move from the center to one of the foci, I moved 2. So my c, sorry, it's not going to equal 1. It's going to equal c squared. So my c is going to equal 1. Sorry, my c is going to equal 2 because I moved 2 to get to my foci. So 2 squared equals 3 squared minus a squared. So 9 minus a squared is going to equal 4. Subtract the 9 from both sides, and negative a squared equals negative 5. So a squared is going to equal 5. So now we're just going to take that and plug it in. So I get x squared over 5 plus y squared over 9 equals 1. And that would be the equation for that ellipse. All right, what if the center is off 0, 0? So the equation, find the equation of ellipse whose center is at 2, negative 3, one focus is at 3, negative 3, and one vertex is at 5, negative 3. So we have the center is at 2, negative 3. So there's my center. And then it has a focus at 3, negative 3. So 3, negative 3, there is a focus. And then it has a vertex at 5, negative 3. So 1, 2, 3, 4, 5, negative 3. So there's a vertex, there's the center. And so to move from the center to the vertex, we started at 2 and we moved over to 5. So to move to the vertex, we moved 3. So to move to the other vertex, we'll move 3 in the opposite direction. So 1, 2, 3. So my other vertex would be at the point negative 1, negative 3. And so we know that it's going to be a left and right ellipse. So it's going to be x squared over a squared plus y squared over b squared equals 1. And so my center is at 2, negative 3. So it's going to be x minus 2 squared over a squared plus y plus 3 squared over b squared equals 1. We know that we moved 3 left and right to get to our vertices. So a is going to equal 3. So now I have x minus 2 squared over 9 plus y plus 3 squared over b squared equals 1. So now for my equation for my foci, a squared minus b squared equals 1 because a is greater than b. And so this is going to be, sorry, doesn't equal 1, equals c squared. So 9 minus b squared equals, to move from the center to a foci, I moved 1. So c in this case is going to be 1. So I have 9 minus b squared equals 1. Subtract the 9, and negative b squared equals negative 8. So b squared is going to equal 8. So plug it in, and the equation for this ellipse will be x minus 2 squared over 9 plus y plus 3 squared over 8 equals 1. All right. What if the ellipse is in standard form? It's not in center form. So if I go and want to change this, your steps are, first you're going to rewrite it, get your x squared and your x, your y squared and your y to equal the number. And then step 2 is you're going to complete the square for the x and the y's. So get it in the proper order. So 4x squared, and then minus 8x, and then plus y squared plus 4y equals negative 4. So regroup the x squared and the x, the y squared and the y, and it's going to equal the number. To complete the square, if it's not just x squared, the first step is we would have to factor out that a term. So we're going to factor out that 4. So it's going to be 4 and then parentheses x minus 2, x squared minus 2x, and then plus y squared plus 4y equals negative 4. And now we complete the square. So remember, to complete the square, you take the b term divided by 2 and square the answer. So for the x's, I'm going to take negative 2 squared and then negative 2 divided by 2 squared. So that's going to be positive 1. But whatever I do to one side, I have to do the other. But I'm not just adding 1 to that side. I'm actually adding 4 times 1 since I factored out that 4. So I'm going to add 4 to the right side to keep the equation balanced. And now for the y's, I'm going to take the b term, divide by 2 and square it. So 4 divided by 2 is 2. 2 squared is 4. So I'm going to add 4 to complete the square for y's. Whatever I do to the left side, I have to do to the right side. So I'm going to add 4 to the right side. And then after I complete the square, now I'm going to factor. So I'm going to factor both of those. So I have 4, and then x squared minus 2x plus 1 factors into x minus 1. So that'll be x minus 1 squared. And then plus y squared plus 4y plus 4 factors into y plus 2y plus 2. So that'll be y plus 2 squared. And then equals negative 4 plus 4 plus 4 is 4. Well, I'm almost there, but remember, for ellipses, the equation has to equal 1. Right now it equals 4, so I'm going to divide all of the parts by 4. And I get x minus 1 squared over 1 plus y plus 2 squared over 4 equals 1. So now I have an ellipse whose center is at the point 1, negative 2, and it's longer up and down. So 1, negative 2 would be the center, and then I'm going to move 1 left and right, and I'm going to move 2 up and down. And so that would be the graph of that ellipse. And we could check on Desmos. And so if I were to graph both the original and our factored form into Desmos, so the original was 4x squared plus y squared minus 8x plus 4y plus 4 equals 0. So notice we have that ellipse. Or our new form that we figured out, we would have x minus 1 squared, and then divided by 1, and then plus y plus 2 squared divided by 4, and then equals 1. And notice it's the exact same ellipse, and it's the ellipse we graphed. All right. The Whispering Gallery in the Museum of Science and Industry in Chicago can be modeled by the top half of a 3-dimensional ellipse, which is called an ellipsoid. The gallery is 47.3 feet long. The distance from the center of the room to the foci is 20.3 feet. Find an equation that describes the shape of the room. How high is the room at its center? All right, so if we put this on a coordinate plane, and let's just call the center at 0, 0, and it's a half ellipse, so we're just going to draw the top half. And it said that the gallery is 47.3 feet long. So all the way across is 47.3 feet. And the distance from the center of the room to a foci is going to be 20.3 feet. All right, so if we took 47.3 and divided it by 2, then all the way across from the center is going to be 23.65 feet, and then this would be negative 23.65 feet. So that is the distance that I move from the center to each side of the room if the center is in the middle. And all the way across the room is 47.3 feet. So this is going to be x squared over a squared plus y squared over b squared equals 1. The center of the room we made at 0, 0. So then it's going to be x squared over a, where a is 23.65. So we're going to take 23.65 and square it. And so that is going to be 559.3225 plus y squared over, I don't know what the b squared is going to equal 1. Well, they gave us the foci. So we know to find a foci, we're going to use the equation a squared minus b squared equals c squared. A squared is 559.3225, then minus b squared equals c squared. Well, they told us that the distance from the center of the foci was 20.3 feet squared. Oops. And so we're going to take 20.3, whoops. We're going to take 20.3 feet and square it. And then we're going to subtract the 559.3225, and that's going to give us negative b squared. So negative b squared is going to equal negative 55. Oops. I forgot the decimal point. Negative 559, then 0.3225 is going to equal negative 147.2325. So the equation for this ellipse is going to be x squared over 559.3225 plus y squared over 147.2325 equals 1. So to figure out the distance, or how tall the room is from the center, we need to find b. Well, we know b squared is 147.2325. So if I took the square root of that, we get the square root of 147.2325. Then the height of that room is going to be about 12.13 feet. So this distance right here would be 12.13 feet, which would be the height of the room at its center. All right, your homework is from 10.3. Let me know if you have any